Good morning, everyone. So we started doing Terraform module development. Okay, so we started with VPC module development so that any users in your company can use that module to create the VPC resources. Okay, VPC is not just the VPC. We need to have subnets and then route tables, associations, internet gateway, and NAT gateway. So everything. So while today I will repeat again, okay, with some standard things, okay, and you will understand how can you restrict users in particular resources. Okay, so we'll discuss that. So we have to convert as two persons, module developer, okay, and then module user. So you need to switch your minds as two roles, module developer and then module user. Module developer is not doing anything strange. He's not doing anything wonder. So whatever we learned till now, the resource creation. So resource definitions or creations are here. Variables are must, okay, because different projects have different requirements. And we will use data sources, locals, and functions to do particular things. Okay. The module developer has to give documentation about inputs and outputs. So it's module developer responsibility to provide the outputs as well, because we need to use those output to create other resources. For example, we are creating VPC. We need to have VPC ID to create security group, because security group needs VPC ID as an argument. Okay. So yes, and module user, he need to provide variables or inputs according to documentation. Okay, so this is what we are doing. So nothing strange. Whatever the concepts we learned, we are just applying here as one requirement. Okay, so nothing different here. So you should not confuse. You should focus. So today, VPC module we are going to develop. So let us have few conditions. We should not allow user to create resources. We should only allow, we should only allow user to create resources in 1A and 1B region. He can give any region, but we need to fetch 1A and 1B region automatically. We should not give him the chance. We should only accept two public, private, and database subnets. Okay, if he tries to give more, then we need to throw an error. Okay, and let's ask project name from user, so that we can give some naming convention like project name hyphen public hyphen agent. Okay, so this is one naming convention for the subnet, and then another naming convention is like this, private, and then another naming convention for database is like this. Okay, so we should do it automatically. We don't need to ask the user to provide public subnet names. Okay, so this is our responsibility as a module developer. Okay, understand these things. Now we will implement. So let me create another repo, Terraform AWS VPC. For example, I'm just giving as something advanced. Okay, so this is module developer. He's developing the module. So first he will give main.tf and then variables.tf. Okay, I'll create another folder for the user. Okay, parallelly we need to test because we are RoboShop infra user. So we are doing both development and then we are consuming the module, right? So you need to switch your mind generally. So first, let us create VPC. Okay. So let me take the AWS VPC Terraform. So this is the VPC definition. Okay, you can keep anything, the name. So CIDR block, let us ask user to provide because it's his wish generally. var.CIDR block. So if you are creating var dot here, you should mention this in variables.tf. You should declare here variable CIDR block. I'm leaving, not giving any default value because I am forcing user. Okay, forcing user to provide value. Instance tenancy by default, it is default. And then, so we have something like enable DNS host names generally. This we will give for DNS to work. var.enable DNS host names. Okay, this is mandatory. This should be the key. Here you can keep it anything. This is your vision. This is under your control. This is Terraform AWS syntax. And then enable DNS support, var.enable DNS support. So I'm keeping this in variables. Default equal to true. So that this is optional because we gave default value. Okay. And then variable DNS support. So we are doing it this second time. So I think it is very much clear to you guys. So tags, let us do something, the merge function. Okay, var.common tags colon. So I'm giving, this is another map. So merge function will always merge multiple maps. Okay, I'm giving name equal to var.project name. And user can still give tags related to VPC. Okay, so let me make common tags optional, VPC tag optional, but project name is required. Variable project name. This is required. Variable common tags. This is optional, but it is always good to give the tags. Okay, and then variable VPC tags. Even optional, it is good to give tags. Or you can make it mandatory also according to your company requirement. Okay, so this is the resource definition module developer wrote. And then we need to test this anyhow. Generally, let us give provider.tf. Okay, I'm taking this provider definition. Okay, and I'm giving vpc.tf. I'm calling module VPC. You always should give source. Okay, so whatever the variables mandatory in the module, so you must provide them. Okay, for example, project name. Okay, so this is from the module. This is from the module variable. You can hard code here like RoboShop. So instead of hard coding, you can always give again your own variable. This is your own variable. You can give the same key name or it's your wish. Okay. Instead of hard coding, we are keeping in variables.kf. Okay. That's it. And what else is required? CIDR block, var.CIDR block. And then let us give common tags. Okay. So I'm giving, this is the variables related to the user. Variable project name, I'm giving default equal to RoboShop. And then variable CIDR block, I'm giving default equal to 10.0.0.0/16. Variable common tags. So common tags for the entire project, these are the common tags. Okay. Project equal to RoboShop, so that anybody can understand this resource belongs to RoboShop project. Environment, dev, and then Terraform true. Okay, so VPC tags no need because we already giving the project name. That is enough. You will get the VPC name. If you want, you can give VPC tags also. Okay, so we provided everything. So let's hope RoboShop infra user Terraform init. This may be caused unusually long delays in S3 processing. Actually, today morning I deleted content in S3. Let me change the key. For instance, we configure. I think this is the problem in DynamoDB. I manually deleted today morning, but you should not do that. Okay, so Terraform plan. Terraform apply. This will create the VPC. And the next thing, it is module developer responsibility to provide the outputs also, because we we need VPC ID to create other resources, for example, security group. Okay, so we need that. So module developer generally will create outputs dot tf, and for example, one output VPC underscore ID value equal to AWS underscore VPC main dot ID. So this is the output module developer is giving, and we need to catch that as a user. Okay, for example, so let me give one outputs dot tf here in user. Okay, output VPC ID equal to value equal to what is your module dot VPC dot VPC ID. Okay, so the convention is module dot name dot output variable name. Okay, so now let us go and then check. So we got the output. Okay, so generally what we do here is we will create one locals dot tf inside locals VPC underscore ID equal to module dot VPC dot VPC ID, so that you can anytime refer local dot VPC ID. No need to give this much module dot VPC dot VPC ID. No need to give everywhere. Okay, I'm commenting for now. So what? Sorry. So what I'm doing here, I'm catching that output into one locals variable. So that is what locals advantage, right? You can store the intermediate values. Okay, so that is about the VPC. So now AWS Internet Gateway, we have that already created yesterday. For example, let me copy that. So this is the Internet Gateway main VPC and merge common tags, and then IGW Internet Gateway tags, and then you can give this name also. Okay. So now you need to declare this in variables, variable IGW tags. So make it optional by giving default equal to like this. Okay, now the Internet Gateway will be created. Let us just check. So generally we don't need Internet Gateway. So you can ignore, you don't need to give the output to the user. And the next thing is very important. We discussed, we need to fetch automatically the availability zones. We should not ask user. If you ask user, he may create 5-6 availability zones, and he may create, it will give US East 1D, 1E, but our company decided to have the resources only in 1A and 1B for better maintenance and less cost. Okay, so now let us just check Terraform to fetch first two availability zones in AWS. So we have the data source. You can give like this: data AWS availability zones available. So what this data source will do is it will fetch the availability zones for the region. Okay. So here I am giving data.tf. So our module developer is getting the querying the AWS, and then he is asking the availability zones. So how he get the region, which region? So the region is always provided by the user. You can see that in our provider.tf. So this is the region. So according to this region, it will, our module developer will pull the availability zones. Where is it? So these are the availability zones. So out of this, we need to get, okay, let me give output and then agents value equal to data dot AWS availability zones dot available dot. Let me give till here, and then in our outputs, I'm just testing output agents value equal to module dot vpc dot agents. Let us see what is the output we get. Okay, we should get the availability zones information. Okay, so this is the entire information you got. So this is US East 1 region. So inside that we have almost how many? 3, 4, 5, 6 availability zones. I want first two. Okay. So if you see this dot names, if you give dot names, you will get this list. So let me give dot names. Okay. Or let me give here directly dot names. So now you will only get the names. So now you got the list. You can see this. This is the list. Okay. So out of this, I want the first two. So again, Terraform to select first two in a list. So the function is slice function. So slice is the function. You can provide your list and then you can select your start index, end index. You can see this start index is inclusive. For example, if you give 0, it will fetch from 0, while end index is exclusive. If you give 2, then it will select 0, 1. If you give 4, it will select 0, 1, 2, 3. If you give 3, it will select 0, 1, 2. So this is the function, slice function. So what I do here is I can create one locals.tf ajets equal to slice function of. So I'm removing this just for intermediate purpose. I gave it here. Okay. Slice of. So this is the list. You know that it is giving the first, the 6. And out of this, I want 0 index and 2. While 2 is exclusive, it will only give 0 and 1. Okay. Yeah, that's it. So for the testing purpose, I'm just writing output agents value equal to local dot agents. So this is for testing purpose only. And then, yeah, now you can try. Okay, now you got the first two agents dynamically. So now we no need to ask the user. Okay, I'm removing this since it's temporary thing. Okay, and then yeah. So we are fetching dynamically the first two availability zones from AWS using data source, and then I'm storing it in a variable called local.agents. So now let us create the public subnet. Okay. So where.public subnet CIDR user has to provide variable public subnet CIDR user has to provide. Okay, but we want only two. If he gives three subnet CIDR, we should say an error. So there is validation, Terraform variable validation to give only list as two. Okay, so you can just check here. There is a validation. So you can mention type also list. Okay, so that users will understand he has to provide the list. And then, so this is the size actually. Terraform variables validation for size of list. Okay, you can see this condition length of, so condition is length of var dot public subnet CIDR, okay, should be equal to 2. This is the condition. If user tries to give 1 or 3, then we are throwing error. Okay, please provide 2 public subnet CIDR. So as a module developer, you are restricting. Okay, so that is that one, and APC ID, and this is fine. They are giving it to, and here it's not var.agents, it is local.agents of count.index. So why I kept in local? Just think. So if I keep it in variable, users can always override. But if you keep it in locals, there is no chance for users to override. This is one of the best advantage of locals. So you know locals, what is locals? Locals is just like variables. We can have key value pairs, but it can store the intermediate values, like it can validate the expressions, it can run some conditions. Based on that, it can get the runtime value. So this is what you know about locals. But one more advantage, if you keep some value in locals, users cannot override. Okay, so you are restricting users to override the values. That is one of the advantage of locals. Okay, so now here let us keep common tags, and then we no need to ask the names. We can just get var.project name hyphen. Let me keep it in a string. And if you keep it in a string, you need to provide like this: hyphen public hyphen dollar, like this. Okay, so now what will happen? RoboShop public US East 1A. So it will be in 1A region. RoboShop public US East 1B, so that users can easily understand when creating the users, when creating the subnets. Okay, so now let us test here by providing this in our VPC. So we need to give public subnet CIDR var.public subnet CIDR. Okay, and then here in variables. So first, let me try to give something like single. Let us test whether we will get the error or not. /24. Okay, let us go for plan. Because in the plan stage itself, we need to get the error. So what is it saying? Please provide two public subnet CIDR. So now we are forcing user to provide exactly two 10.0.2.0/24. So now you can get it. And we need this public subnets again as output so that users can use while launching the AWS instance. Okay, so we need to provide output public subnet IDs. Okay, so value equal to AWS underscore subnet dot public of star. It means all dot ID. So we can store it. Public subnet IDs equal to module dot VPC dot public subnet IDs. Okay, for the testing purpose, I'm just storing here. I mean, just printing here. Okay. So this VPC, whatever we are using, so this is the VPC for the entire RoboShop project. In future, you may get another projects like ratings, dispatch, and some other modules, components are getting continuously added to our RoboShop project, right? So when the time is going on, we may get a lot of components in future. So at that time, again, you need to use the same VPC ID, those things. So that's why I'm storing here. So now you've got the public subnet IDs. Okay, so now let us do the same thing with our private. So as a module developer, I'm creating two. So this is private subnet CIDR, private subnet CIDR, and then let's make it private. Okay, that's it. And then variables, same, except only two. Okay. Similarly, let us go for database also. database subnet CIDR. Okay, let me give it here, database. We are creating to public, to private, and then to database subnet CIDR. So audio developer created the variables, and it's our responsibility to send the information. Private subnet CIDR, var dot private subnet CIDR. Let me create the variables. Private subnet CIDR. I'm just taking it from 11. Okay, in future, you're reserving 3, 4, 5, 6 for again something else. Okay, maybe in another region. Okay, this is database. Okay, and again, it's module developer responsibility to give the outputs. Okay. Now user can store that in a local value so that he can use while creating another resources. For the testing purpose, let me just print. We don't need to print, just for us to test. Okay, I think everything is good. So now let us apply directly and then check. Okay, so we got the all public, private, and database subnets created. Okay, the next thing is the route tables, sorry. Route table and association. This is public, sorry, this is route. Okay, let me get something. AWS route table Terraform. So this is public route table and AWS VPC main.id, and the public route table you should always give internet AWS. So I'm adding route directly here. So I'm creating public route table. I'm adding the internet route. If you add internet route, then only it is called, it will function as public route table. Okay, otherwise no. And I did a simple thing here. So public subnet. So let me show you something. AWS subnet Terraform. So public subnet means I want public IP. So let us just check RoboShop. So in this here I'm provisioning web instance inside public subnet. Okay, it means I need public IP for web instance. So that's why while creating public subnet, we have an option that is public IP. Whenever you launch, you can see map public IP on launch. Whenever you launch an instance inside this public subnet, so we are asking to give, map public IP on launch true. So we are asking to give public IP address. Okay, so if you provision any EC2 instance in this subnet, by default you will get public IP. But in private and database subnets, you will not get public IP. Okay. That is the difference. So yeah, we don't need this for now. And tags, again, the same strategy, merge var dot common tags name equal to var dot project name colon public, so that anybody can see this is public route table. Similarly, for private and database subnets, we need to discuss something called NAT. NAT gateway. What is NAT gateway? Okay, so what is NAT gateway generally? Today we have seen the example, right? Insert concepts. Let me go that. Just imagine here. Here, this is the PM office. If you want to go to PM office directly, you are not allowed. But if PM wants to meet you, so you will get the call from PM office. Okay. So incoming is called as ingress. Your incoming is blocked. You cannot enter directly. But outgoing is not blocked. If PM wants to meet you, he can directly meet you. So that is like NAT gateway. So inside, this is the subnet, database subnet. If you want to connect to the database subnet directly, you cannot. Okay, you are restricted. So if database wants to connect to the internet, database server wants to connect to the internet. Why database server wants to connect to the internet? Because we need like any server, if it wants to install some packages, it needs to connect internet. Okay, not only install or update some packages. Okay, just like your Windows server. So you can work, sorry, Windows laptop, you can work without internet. But if you want to install some packages, some softwares, you need to connect to the internet. So same here. So incoming is blocked. So you are secure. Nobody can hack your database server. But outgoing, you are intentionally connecting to some softwares for installations or updates. So that is why NAT gateway. So NAT gateway allows NAT gateway will give you internet to the private servers. Okay, but that is only outgoing internet, not incoming. So that's what AWS documentation also says. You can use NAT gateway so that instances in private subnet can connect to the services outside of your VPC. So if you will get this question in interviews, that's for sure. What is NAT gateway? So then you have to say, if the instances in private subnets wants to connect to the internet, then we can add NAT gateway to the private route table so that instances can connect to the internet. So that is NAT gateway. So there are few rules for NAT gateway. The condition is it should have elastic IP. So what is elastic IP? So here, what is my IP if I type? So this is my IP address, IPv4 address. But tomorrow, if I search and tomorrow, if I check again, this IP address is not permanent. It may change. Okay. So generally, ISP will give dynamic IP address. Okay. So the same thing, whenever you stop the EC2 instance and then start again, so it's not guaranteed you will get the same IP address. Okay. But if you have static IP, so we can always request, you can always request ISP to provide static IP. But they charge like 1,000 rupees or 500 in India. But your IP address will never change, right? So that is the advantage of static IP. The same thing here, we call it as elastic IP. So the condition for NAT is your IP address should never change. So that's why you should always attach elastic IP. So getting elastic IP is very simple. So I think AWS will charge $5 per month. Okay. But you should delete it whenever you are not using. Elastic IP can just allocate elastic IP. It's asking the region and then allocate. That's it. You are getting one public IP. You can associate this with any instance. Okay. Let me delete this. So now we need to create one elastic IP, and then we need to create one NAT gateway, and we need to add that as route in private and database route tables. Okay, so that instances in private subnet and database subnet can connect to the internet and fetch the updates. Okay, so this is very important question generally. So now before going for private subnet and database subnet, so let me get AWS Elastic IP Terraform. Okay. I'm not associating with any instance. Okay. I'm naming it as Elastic IP and now NAT gateway Terraform. Okay, so you can see this to ensure proper ordering. It is recommended to add explicit dependency on the internet gateway for the VPC. So you will get this question in interviews sometimes. What is depends on in Terraform? So you can say Terraform in maximum cases, Terraform can understand the dependency between the services, but for few conditions we need to, for few scenarios we need to explicitly mention. Okay, so that is what I'm saying here, AWS Internet Gateway dot main and allocation AWS EI. So as I said, we need one elastic IP here. So that is ID and this one more thing, NAT gateway. NAT gateway, which subnet you need to provision. So which subnet we have the internet access? Can someone please type? Which subnet has internet access? Yeah, public subnet. So we have public subnet, we have private subnet, and then we have database subnet, right? So this subnet has internet access. So internet access through internet gateway. Like this is a modem. So what AWS should do here is generally, so they will provision NAT gateway in public subnet. So now your instances in private subnet will connect to NAT, and your database subnets and instances in database subnets again connect to the NAT gateway that should be in public subnet. So now it will reach the internet through internet gateway and here. Okay. So that is why here we explicitly mentioned internet gateway is mandatory to create. Okay. So remember this. So they will ask what is NAT gateway, where you provision NAT gateway, why you need to provision in public subnet, because we want the internet connectivity to the instances in private and database subnets. So for that, we will provision the NAT gateway in public subnet that has internet access. Okay. So it's just like you are asking one person help who can connect to the internet. That's it. Like you have your laptop, you don't have any modem, you don't have any internet connected. You can switch on your Wi-Fi hotspot from your mobile. Then your laptop will connect to your mobile hotspot, and from there it will go to the internet. The same way here it is happening. So it should be always AWS subnet public and then 0.id. Why it is 0? Because we have two subnets, public of 0, public of 1, public of 1. So I'm provisioning everything in US East 1 game, okay, to save the cost. If something happens, then you can shift the resources to the US East 1B. Again, the same thing, var.common tags and then name equal to var.project name. And you can always give NAT gateway tags. NAT gateway. So NAT gateway tags. Okay, very important for interviews, just prepare this. So we need to define the variables, what variables? NAT gateway tags. And this is by default, optional. Replace example to main for that gateway. Thank you. So now the next thing is to create private route, and then let me copy the same. Private route table and then database route table. So this is private, and then now the route is internet, but it should be to the NAT gateway ID. Okay. So what is the NAT gateway ID? AWS NAT gateway.main.id. So in public route table, you are connecting to the internet through the internet gateway. But in private route table, you are connecting to the internet through NAT gateway. That is the only difference. So we can give option to provide private route table tags for the users. It's their wish. Similarly, let us give options also here in public. So we need to declare it variable public route table tags and then variable private route table tags. So we are making minimum inputs to the users, CIDR block and project name, and then public subnet CIDR, private subnet CIDR, database subnet CIDR. Okay, let us create till here and then check. Terraform apply, sorry. Any things we need to give as mandatory? No, I think. So we got some error. What is the error? 105. It's already declared public. So some copy paste mistake. AWS route table public. Duplicate resource AWS route table configuration. Declared 69. Oh, you're already created route table. Then why I create again? So remove this. This is private. Okay, and then later we can create database. I'm just following whatever we discussed here. It is getting created now. You can check. Here we will have an elastic IP address, and then our NAT gateway is getting created. Usually it will take a few minutes, like 1 to 2 minutes. Where is NAT gateway? It is in VPC. NAT gateway. Okay, it is getting created. And then you can check the subnets. We got all the subnets, US East 1A, 1B. So by seeing this, anybody can understand. Without going to the right side, anybody can understand. So this is database subnet, it is in 1A. This is private subnet, it is in 1A. So this is public subnet, it is in 1B. And then route tables, we got public subnet. Okay, we need to do the associations. So still NAT gateway is getting created. It will generally take 2 minutes. So that gateway is chargeable. So you need to delete it whenever you don't use. Okay, it is available. So now we can check our route tables. Photoshop public route table. You can see we have internet gateway. That is why it is called as public route table or public subnet generally. If you attach this route table, and we got private route table. can just check the route internet is added through NAT gateway. So NAT gateway will only allow outgoing connection. It will not allow incoming connection. So that is the advantage. So let us create our database route table. The same route you can keep. That's it. Let me create this variable. Okay. That's it. Database route table will be created. Now we need associations. Subnets should be associated with route tables, right? So we have created yesterday and just copy it. So this is the public association. So yes. So first it is iterating 2 times because we have 2 public subnets. First time it will get the, it will get the count 2 and it will get the first public subnet and then it will attach with public route table. Second time it will get the second public subnet, it will attach with route table. Okay. Private and then here private subnet CIDR and this is database and then it is database subnet CIDR. Okay, that's it. Now the associations are done. So let us do once again. Okay, it is done. Now let us check. All the associations are done. Let me check database. So this is associated with our database subnets and the routes are properly added. Okay, finally, we need to group our database subnets generally for database creation that you will understand in upcoming sessions. But that is a simple AWS database subnet group. Terraform. So this is for database creation generally. Okay. I'm mentioning it as shop name equal to var dot project name and then what are the database subnet IDs? AWS subnet dot database. So we have AWS subnet, right? AWS subnet dot database of star dot ID. So we are just creating a group, database subnet group. So that is generally again merge var dot common tags and then name equal to var dot project name and you can give var dot db subnet group tags. Let us make this as optional. That's it. So now let us apply. So where you can see this is inside RDS console. Generally, here there will be database, dashboard databases, and then subnet groups. Okay, generally you can find here. So this will be useful while creating our databases like MySQL. Okay, yeah, so that's it. So our module development is over. Our VPC module development is over. So let us check outputs. Are we providing? So yeah, these outputs are enough generally for users. If they want more outputs, you can always come and then create one more output value. Okay. So yeah, that's it. So now our module development is over. Let me push to the GitHub. Terraform AWS VPC advanced. Okay. Public. Check availability. Yeah. Create repository. So first, let me destroy the resources. Or let me keep it, no problem. Terraform AWS VPC advanced git init git remote add origin. So if you just check here, RoboShop infra user, so I'm referring to the local directory. So this is the local folder here, but I want to refer it from the internet. How can you refer? If you keep it in GitHub. Okay, now the module is in GitHub, and just how to refer Terraform module from GitHub. Okay, so in your module definition, now in the source, you should give like this. Okay, so let me just check with another project like Amazon infra. Okay, so here you need to give vpc.tf and then provider.tf. So inside provider, let me copy this. Okay, so now the module you developed and then push to the GitHub. Like you are working for Amazon company. For Amazon company, you developed AWS VPC module and then you pushed. So then the users in Amazon, they have to use your module. So how can they use? I'm just keeping it as Amazon. Okay, inside VPC. Now module VPC and then source equal to this one. Copy and should be SSH. This one, HTTPS. Okay, so this is the source because that module is not available in their laptop. And now you can start giving the variables. Okay, so let me take the this is the project name and variables. Now I'll change the variables. variables dot tf. Okay, I can only change this Amazon. Okay, that's it. Now it is that much simple. Now let us just check cd Amazon Terraform init. See, it is downloading the module from GitHub. You can just check here. Your entire code will be here. You can see whatever you wrote as a module developer, everything is here. That's what it is doing, nothing much. Now let us apply. So within few minutes, you can create the infrastructure using modules. Okay, now let us check. Now Amazon VPC is created. Amazon subnets are created. Amazon route tables will be created. So everything will be created. Amazon NAT gateway also will be created. So it is that much simple if you do the development properly. Okay. Now, whenever you change something here, whenever you change, you added some extra output. Again, you need to go for git init update. For example, let me just output something, some update value equal to updated again, something just for testing purpose. So let it create. So let me push this. Oh, this is getting created. So what I mean to say here is whenever you update the module as developer, you need to push to the GitHub and the users, they have to fetch it again. Okay, everything is done. So now I updated something, right? Module.vpc.some update. So now if you get here outputs.tf, okay. Output testing update value equal to module.vpc some update. So just imagine module developer did some updates and then he has to push obviously. If you try to get that, okay, if you try to print, so you should get an error. Okay, you can see why, because the modules already downloaded here. So if you want to get the updates, you just give terraform init ---- help. So there is a command for update. Backend input. Yeah, you can see upgrade. Install the latest module. Okay, terraform init upgrade. So when he changed something and he pushed to GitHub, he will announce in your company, okay, this module got updated. Now you can apply, you will get the value. Okay, now you can see you are getting the value. So this is how the ideal module development goes. So I took some more time to make you understand about how can you develop a module. So this is one way. You can develop your own module, or we can have our Terraform open source modules. Open source modules. So if you go to that, it's directly in GitHub, generally. So this is from Terraform itself. Okay, you can check all the modules available, like VPC module. So like however we develop, so they also develop, and you can check here source. By default, it is in GitHub, so you can always source select like this. This is the source from GitHub, like this one. Okay, and you can provide the variables like this. Okay, so the same way how they develop Terraform developed open source modules, the same way we develop, just need to add the documentation. You need to tell your user what are the mandatory values, what are the optional values, like we did yesterday. Okay, so that's it. So generally some projects, they don't prefer to develop the module from the scratch. They prefer to use the open source modules. And then some projects, they prefer to develop from the scratch. Okay, so both have advantages and disadvantages. From open source modules versus own modules. So this is a debatable topic. So there is no right and wrong. As per the business requirement, as per the project requirement, you should go. So the advantage of open source module is you don't need to develop from the scratch. Everything, the best practices, everything can be taken care by the community. But if you develop, if there is some defect, if there is something wrong here, so you need to wait until they give you the update. Okay, so but Terraform module development is not a tough thing. Ultimately, we are writing the resource definitions to create the resources. There is nothing difficult here. So sometimes they say, like in banking companies, so you don't need to depend on the internet to give you some update, to give you some fix for the defect. So you don't need to depend on the internet. This is very simple. So not a tough thing. You are not doing any new things here. You are just creating resource definitions in the modules. So go for own development. Some projects, like simple projects or small projects, so they don't want to spend time on the module development, so that in that point of time they can go for open source modules. Okay, so that's it. You can read from the internet. This is the actual summary. Okay, so you can just read this. So he is liking public modules. Okay. And he is saying I use a mix of copied and customized modules. So there is nothing, there is no right answer, wrong answer in software. Everything is as per the requirement. So that's why I'm just teaching you both. How can you create your own modules? And for some other projects, we can, some for other resources, we will use the open source module so that you will be ready to do anything. And for a simple resource, you can just write direct resource definition generally. So yeah, we can stop till here today. And then let's accept few questions. Yes, Sattar.
Am I audible? Sivareddy.
Yes.
Super. Yeah, hi, Sukumar. Like you are saying Terraform module, okay. But like still, how many days remain to complete this course and for the guidance of the resume preparation, everything?
It's a 3.5 months or 4 months course. We just completed maximum 1.5 months. Yeah.
Only okay. It will take 2 more months. You are saying,
Yes.
right?
Yes, correct.
Okay. Like resection is going on, right? Like next year it will be like no resection.
Okay, so these kind of questions we can discuss in the evening QA session.
Okay, thank you.
So any questions related to this Terraform, you can ask.
Nothing. That's it.
Thank you so much. Kodur Sai Kumar. Kodur Sai Kumar. Praveen Kottapalli.
Yeah, hi, sure. Good morning.
Yeah, hi, good morning.
Shiva, I think this is a normal question. So, I mean, regarding this session only. So, you are auto approving, applying and auto approving in resources, right? And after that, you are adding something extra like any other resource, and again you are auto approving, right? At that
Yeah.
time, what will happen in backend? Like it will override the existing ones, uh,
No,
no, or it will add only the
just
latest.
like Terraform plan is just to make you understand what are the resources going to be added. So it is mandatory generally when you do some change here, it is mandatory to run the Terraform plan and understand what is happening to your resources. Okay, but just to save some time in the class, I'm directly applying.
Okay,
But
okay,
ideally you should plan and then you should check what are the changes in the resources and is it is going to do any damage, and then if you are sure, then only you can apply.
okay. So one more question. So is the only one way we get to know that our code is having issues or not? To get to know that we're using the Terraform plan, or any other way we have?
Terraform plan only you should understand. So what are the changes happening? That's the only way.
Yeah, even if we can see that if we
You
face any
can
issue or
see Terraform validate for the syntax. Okay, but Terraform plan is automatically running this command in background. Terraform validate.
okay,
Okay.
okay, if any issue is there, we can see here issue also, right?
Yes.
Okay, I have one question last time also. Uh, so the same. So there is an interview question like, what is the difference between pull and fetch?
Pull and fetch. That is related to the Git.
Yes, yes, the Git or some here also, right? If we have any updates in this code also, we can use the same. Or,
Pull is nothing but you are pulling the changes. So that actually you will understand when we discuss the full-fledged Git. Okay, generally pull equal to fetch plus merge.
okay,
Okay, that you
okay,
may not understand right now.
okay, okay. Sure.
Yeah.
Thank you. Yep. Thank you.
Okay, most of them. And then Yashwant.
Hi Siva, can you hear me?
Yes, I can hear you.
Yeah, same thing like the previous person was also asking. So when we for this one, first we created the public and private subnets, right? After
Yeah.
that, when we are approving, like applying the route table, so we did step by step, right? So when we are trying to apply the route table, will it again create the public
No, it
and
will not create. That's
it will not-
what
okay.
that's what the terraform.tf state and that state we discussed.
Okay.
The Terraform
It will
will
just-
compare your TF files
Okay.
with the state, and then it will understand, okay, it is already created. Why should I create? So that's why
Okay.
it will do that.
Yeah, perfect.
Now, if you
yeah.
run Terraform plan, yeah.
Yeah, I'm good, Shiva. And one more question is like, in Ansible, is there anything similar to this state file, or like we don't do that?
No,
in
Ansible is different concept. This is different
Okay.
concept. Yeah.
Okay. I'm good. Thank you.
Yeah. Welcome. Srinu?
Shiva, if you don't mind, one more question.
Yes.
Yeah, so can we do the same configuration what we are doing in Ansible using the Terraform also?
Ansible is different. Terraform is different.
Yeah, because I got to know that we can also use entire Terraform also for in configuration purpose.
No, Ansible, you can use it for infrastructure as a code. Using Ansible, you can create EC2 instances.
Yeah, that's the same way we can also use the Terraform for configuration purpose.
No, you cannot.
Okay, thank you.
Hi Shiva, good morning.
Who is this? Yeah, Srinu?
Yeah, actually I had a small doubt regarding giving tags. Can you go to one tags that
Yes.
module creation? Yeah, here we are giving name, right? Where dot project name.
Hmm.
Why we are mentioning here only? Like we can mention in variables also this one name.
You can mention in common tags also, but sometimes here you can see creating the name dynamically here. So for this purpose only, I just got it.
Okay, for dynamically creating, we are given here. Okay.
Yeah, so tags is completely your wish. You can use it however you want, but just for some naming conventions, I'm just getting it.
Yeah. Okay, got it. Thanks.
Okay. And then Rajashekar Reddy.
Hi Shiva.
Yeah, hi.
My question is availability zones is there, right?
Yeah.
So right now we are taking in the same availability zone east 1A and 1B, right?
Yeah, correct.
So for more availability, I seen some projects in my company. One is one east 1A, another one is a different region.
That is disaster recovery. The
Yes.
high availability means in the same city like California. So we have east, north, west, south, many availability zones.
Yes.
So and if entire California goes down,
Yes.
so like some disaster recovery, like there is a tsunami or something that happens, the entire California goes down. Now you can shift that to the England. So that is disaster recovery.
Okay, for that, is there anything more configuration here? For example,
so that is a big concept actually. First of all, you need to understand. So disaster recovery means there will be a downtime.
Yeah.
Okay, so high availability is there is no downtime. You are just keeping it both in east 1A, 1B. There is no downtime. But disaster recovery, definitely there is a downtime. So it will take some time, at least 1 hour to 1 day also, or 2-3 days also. That is based on lot of things. Okay, you will understand later anyhow.
okay, thank you.
So you need to take the backups. So many things. Yeah.
Okay. Okay, thank you.
Yeah, most welcome. Nishal?
Hi Shiva, good morning.
Yeah, hi.
Can you please go to the code?
What is your question?
Regarding that code only, a bit of right the modules.
Okay.
Yeah, in these modules, as a module developer, we have developed the Terraform AWS VPC Advanced. Okay, all the code we have developed. Simply the user that is the RoboShop infra user, he is just referring this code as a source and referring his own values as a user, right?
Correct.
The same part you have done in the Amazon also. You have given some customization name Amazon, and you have called this source as a given source, and you have called the whichever we have developed this code, right?
Yes.
Terraform AWS. Like that, how many members can able to copy that source? Like
Infinity.
infinity. Can we able to give any log kind of things here? If any person is giving our source code as a module developer, we are developing a code. Okay, if any person is coming and he is developing his own module and giving our source, and he need to he can't able to access that one. Is there any kind of logs or
No, nothing. If you just make it public, anybody in internet can use it.
where we can able to give as a private?
Private, then make the repository as private, and only in your company persons they can only use those modules. For example, if this is really in Amazon, you cannot directly consume Amazon modules, right? You need to prove your authentication. You need to give your username and password.
In that case, we can make our GitHub repositories private, then it will be
Yes.
secure, right?
Yeah.
Oh. Okay. Thanks.
Yeah. Some person Sumuk.
Hello.
Yeah, hi.
Yeah, like in daily basis in company, which data types are used in Terraform most widely?
Everything. There
Everything.
are no much data types here, maximum 5 only.
Okay. So, like just it's a general question. In future, maybe Terraform will take over DevOps role. Terraform role will be more than others, right? Like other side infrastructure services.
So already everything in infrastructure is created by Terraform, not manually.
Okay. So those who using AWS, those who using cloud services, they will must go for Terraform instead of any other source code, infrastructure
Stop
code service.
doing manually. Everybody should move to infrastructure as a code. So we have Terraform. In AWS, we have Cloud Formation. You can also use that. Okay? But Terraform can be used more widely. Okay?
Oh, thank you.
Yeah. Understood. Sheikh Ahmed.
Yeah, Shiva.
Yeah, hi.
So, yeah, in the beginning, actually, we have done some init reconfigure, right? So, what exactly it is doing? Like,
So it was corrupted. Actually, I went to the S3 and then I deleted manually something. So, and there were some locks in DynamoDB. Sometimes locks will not be released. So at that time, you can release the lock. So there's a command Terraform release lock generally. So
okay,
just like this.
you even deleted the few things in DynamoDB, right?
Yeah, I just deleted everything. So yesterday I missed it. I was doing some experiments, so that's why the problem.
So init reconfigure again based on the code we have written, it will again reconfigure there.
Yes.
Okay. And this Amazon infra that you have created, like basing upon the module, so it again recreated few TF files. It copied.
This is I am using again for another project. So I need to provide these values. So that's why I did.
Okay, and you're referring like the few information we'll get from user, right? So who exactly the user is?
Whoever create infrastructure, he is the user.
Okay, like the subnets, whatever we are giving, so those will be given by user itself?
Yes, obviously.
So we won't we won't be given by ourselves.
See,
right?
I'm
Only submit.
just telling how to develop the module.
Hmm.
So it's just development is not enough, right? You need to test it. So in
Yes.
your project, you are the person who should develop and then who should use it. For example, you are the RoboShop DevOps and cloud engineer in a RoboShop company, a RoboShop project. So there will be many projects in upcoming in future. Okay, so that for that purpose, you are developing the module for others, so they can use, or you can use, anybody can use.
Okay. So these testings, as of now, like here we are doing Terraform plan to check what are all adding.
Yes.
So while in real time, like can we also auto approve? We can.
No, you should not auto approve. You should check and then approve.
Okay. So there won't be if you want to test, we can't do that. Only we can see the outputs only.
Yes, you have to see the output properly, understand, then approve.
Okay. Okay. Right.
Okay. Janathan?
Yeah. Hi, Shiva. Good morning.
Yeah, hi.
Yeah, just wanted to check with you because see, this code, I mean, day to day, the code is getting increased, right? Because of so many resources we are creating, and so is there any way like we can validate this code before we execute, maybe as part of the syntax errors or maybe as part of other stuff?
The Terraform validate is for the syntax errors. Generally, when you run Terraform plan in background, it will automatically run that command and it will tell you immediately if there are some syntax change errors.
Okay, so we need not explicitly say Terraform validate. That's what
Yeah, correct. Yes.
Oh, okay. And also, I think there was, I mean, I don't know whether it's the right time to ask, there was one question from one of the interviewer. He said that, okay, he asked me like, okay, you have created the infrastructure on the cloud, and how do you validate that the infrastructure is created according to what you expected? So is there a thing that we can validate the infrastructure that is created out of our Terraform script?
Testing tools available. Okay, so generally you first do it in dev and then you do the same thing in production. So that is the better way. So there are some Terraform testing tools.
Okay.
You have gone through it. So there you need to write some code again to test it.
Okay. Okay.
So just try to at least do some practice with something, like create one EC2 instance using Terraform and using the testing tool, just test it. So, but for that you need to write some code again.
Okay, if anything, if you remember like that kind of testing tools, could you please name it? Maybe one or two.
So something like Terra test.
Terra test. Okay. Okay. Yeah, fine, sure. Maybe I'll work on that and let you know.
So you no need to spend too much time on it. Okay, just do it for one and then tell him. So he will not ask you to write the testing code.
Okay.
So if you are learning development, you no need to learn testing again, but you should have some understanding how they test. Okay.
Okay.
So that's all for today's session. So yeah, so we can have, so this is the last time. So many persons are requesting some leave. It's already holiday on 15th. Okay, you can just holiday tomorrow. Yes or no. So this is the last time. Okay. So we cannot give the holidays like this. So it will take. So I hope everybody wants holiday tomorrow, I think.
Yes, sure. So due to that lack of practice, we are not even getting doubts.
Yeah, consider this is the last time because we already had a lot of gaps. So usually when I'm teaching, obviously we may have some personal works, we have some personal emergencies. So at that time, obviously that will be a holiday. And we are having Saturday and Sunday. Please consider this as the last time. Okay, and then from next time we can try to run the trainings from Monday to Friday. Okay. Thank you so much. See you on next Tuesday. Okay, so I will try to give lot of assignments in these 4-5 days. First you complete this. The immediate assignment for this one, clone it in your laptop and then give the readme.md here. Okay, provide the inputs and outputs, and then you can work on how to use this module, and later you create your own module. Okay, and then push it to your GitHub so that you can keep it in your profile also. So if you keep this in your profile and proper README documentation, so then they will see this GitHub repository, and that's a good opinion on you. Okay, so this guy knows Terraform module development. Okay, yeah. So that's all. See you on Tuesday. Yeah, happy Nayaka Chauthi. Thank you. Bye-bye.
Shiva, thank you.
Bye-bye. See you.